Thank you for coming to the talk, even though it's the last one of the day. I appreciate that. My name is Mike, and today I'm going to be pitching you almost on the concept of bringing back two-tier architecture in the way we build database-backed applications. I'm going to talk about and present a little demo of how to do this, and in doing it in particular with the Jetpack Compose desktop, and you could also do it with mobile, but I'm focusing on desktop today with Kotlin. So what I mean by two-tier architecture, and this, if you ever wrote database apps in the early 90s, you will have done this before, but if not, then two-tier architecture is where you have a database-backed GUI app that is connecting directly to your relational database backend. There's no web servers, there's nothing in between. It's literally a direct connection from one to the other. So I'm going to talk a little bit about why you would do this, what problems motivate this experiment or alternative way of building apps. I'm going to demo some workflows about how you can develop this sort of app and also deploy it with a simple demo which implements things that you might want in a real app, like open sign-up, for example, with email confirmation, things that you wouldn't necessarily associate with an app written this way, but which you can do. And I'm going to argue to you, and this is actually a perfectly viable way to build apps in many cases. I wouldn't do it in every case. I wouldn't try and build Instagram this way or anything like that, but for many apps that are not Instagram, this is, I believe, viable. Now, I don't expect you to agree with me by the end of this talk, but I want to get you to the point where you're saying, that obviously can't work, that's obviously a bad idea because, wait, why, yes, there must be a reason. So that's where I want to get by the end of this talk. And it's worth starting, therefore, with, like, why would you do this? What's wrong with the existing way in which we write software, and what is the motivation for looking at different ways of doing it? So the main motivation is simplicity. A typical database-backed web application today has a very high level of incidental complexity relative to what you might naively expect if you're outside of the software industry. There are multiple programming languages in use at once, usually at least 3 or 4 if you're using something like Kotlin on the back end as well. You've got HTML, CSS, Kotlin, JS maybe even TypeScript or something, which is a sort of language on a language. You may have templating languages, and all of this is really just to put some fields and some GUI on the screen and then update a database with the results. And there's many acronyms to master, right? If you think about what it's like to teach people from scratch, you've got or at least all of these acronyms, and quite possibly a whole bunch more, and that's on top of things like SQL and ORMs and other things to access a database. So there's a lot of different technologies to master, and this leads to, in the end, a lot of boilerplate and, to some extent, busy work, right? You have to do. Web browsers don't really understand databases in any way, and they never have, and the browser makers, even though this is one of the most common use cases for them, do not seem interested in fixing that. So you have to do a lot of mapping between your database and between ad hoc application-specific protocols and that sort of web backend engineering. And you implement ACL checking that your database could already do, but you re-implement it on top inside the web server, and there's a lot of boilerplate and busy work, a lot of frameworks that try and generate this stuff for you, and in the end, it's a lot of work. And because you're doing a lot of application-specific code that's kind of repetitive, but also kind of not, there's many bug classes that are specific to the way we do things. The most obvious is cross-site scripting, of course, which is still one of the top bug classes, and Chrome tried many things to try and stop this at the browser level and eventually gave up because it's fundamental to how the web is designed. There's still SQL injection. It's got less common in modern apps than it once was, but it's still a very, very common bug class. You've got cross-site request forgery, server-side request forgery. You've got broken implementations of authentication protocols. You've got certificate expiry, which is not technically a security bug, but causes massive, extremely expensive outages on a regular basis, and we just sort of shrug and say, what can you do? Cause errors, you've got hacked web servers because they run at a very high level of privilege, so if you get access to the web server in some way, serialization vulnerability or memory corruption or something like that, then it's game over. And even broken single sign-on integrations, which are extremely common, and actually some people recently, they decided we're going to try and hack the web dashboards of every auto manufacturer out there, and they've discovered they could unlock people's cars remotely and things just by exploiting broken well, broken web apps, basically, mostly broken SSO implementations. And then finally, the learnability of this stack, going back to this simplicity, is extremely poor. And the thing that first started me thinking down these lines a few years ago was, at the time, I had a girlfriend, and she decided she wanted to become a computer programmer and learn from scratch. So she signed up for, well, actually, I got for her birthday a boot camp, which was a 9-week course. And it was kind of disastrous because they tried to teach her Ruby on Rails and web stack development from scratch in 9 weeks, starting from 0, which doesn't work. There's just way too many languages and concepts. And the on-ramp is extremely rough. To get to the point where you've got like a basic button that like stores some data so you can reload it and someone else can see it, you have to learn an enormous amount of stuff. And so that drives people to start with markup and then learn a little bit of JavaScript and then go JavaScript on the back end and so on. And that's bad news if you're trying to teach Kotlin to new programmers, because you're going against the grain, and the on-ramp becomes very steep. If you're an experienced programmer, of course, then Kotlin is great because you can pick it up very easily. But if you're starting from 0, then it's quite hard. And then even once you've got it working locally, the deployment experience is discouraging at best. You have to learn at least Unix, maybe Cloud and Docker as well. And of course, these things layer on top of each other. And then, all of that is yet more languages to learn. So there was like a 3-day section of this 9-week course which tried to teach shell scripting, and that was on top of Ruby and JavaScript and CSS and HTML and SQL. So you can see why it doesn't work. If you're trying to learn web dev from scratch in 9 weeks, like you've got to try and master 6 languages in 9 weeks. It's insane. It's not possible. Right? And then finally, we have this new, in recent months, this new large language models. And this leads to something that it doesn't exist, but I decided to call AI optimality for this slide, which is if you want to get help or delegate boilerplate and some work to an AI, you've got a limited context window before they start forgetting things. So the more verbose and boilerplate heavy your code base is, the less effective these new companions are. And you can try and have workarounds, but they don't, they're not ideal. And the best thing, therefore, is just that you're going to get the most out of AI if your code base is concise. And not just concise in terms of Kotlin being a concise language. That's good, that helps. But concise architecturally as well. So you're minimizing the amount of plumbing and boilerplate and moving of stuff around and transforming and all that stuff, so you can get to the core of your problem. So let's drill down a little bit more into what I mean by two-tier architecture in this demo. So it starts with, as you can see, it's a very simple diagram. There's 2 tiers. You've got desktop and mobile, and they are connecting by the native database protocol, the Postgres protocol, the Oracle SQLnet protocol, whatever you're using, deciding to run on the back end. This demo is the Postgres, connecting directly to your master if you are doing a write operation, or to read-only replicas for the bulk of the queries. And every user of your application has a database server user. So you're mapping your users one-to-one to database roles, which sounds a bit strange, but it does work, and it has a bunch of advantages. Like what? Well, why do people like native apps on mobile? There was just a talk by Jake on the lengths these guys go to have native UI on mobile. One reason is very low latency, and if you preload your entire app UI, which if you're distributing onto the desktop you do, then you get very nice low latency UI. There's a little, there's a bit slower in the very first install because the user has to wait, but people tolerate that on mobile just fine. And after that, everything is smooth, and you can get very nice animations, and the UI never pauses. You can get cheaper deployment, obviously, at one level, because the second tier is just gone. You just need fewer servers. But also, you don't need monitoring for them. There's less to go wrong in that sense, and so on. It's obviously easier to learn. You've basically got 2 languages at that point, right? You're trying to learn Kotlin and SQL, and that's just less mental overhead and less mental pressure. You have declarative security because SQL is quite English-like, and you can centralize all of your access control rules in one place, which is just the definitions of your tables and views and row-level security and things. So you can audit your access control in one place. It's not spread out over many handlers. And then one reason the code is so simple is you just work directly with SQL results natively in your UI code. You don't have to serialize to JSON or do anything else. You just do a query and you get back results, and you map them directly through to your UI, to labels and buttons and things like that. So, oh yes, and one final one, right? If for some reason, like this will typically be the case for internal apps at like sophisticated businesses, but if the users of your app are business analysts, for example, or they're people who, are Excel wizards or whatever, then you can actually just say, well, why not? You don't have to use your UI. The users could log into the database backend directly with any tool that knows how to work with databases. And there's lots of tools that work directly with databases and can do all kinds of visualization and interactive querying, which means that if you have a user who needs a very specific query, and maybe that's an important user, but it's just one, you don't face this scheduling problem with your backlog. You can just say, okay, just like go ahead and do it yourself, right? Like the ACLs are set up so that you can do that. You're connecting not with HTTP. You're connecting with protocols that you're probably not deeply familiar with, but they've been around a long time. Relational databases are very mature technology, and the protocols have a lot of features. They have transactions. They can implement RPC via stored procedures. They do batching, streaming and cursors, and all these other nice things. And so all of these are things that you would, in typical web app engineering, you end up re-implementing yourself. If you need paging, you have to implement some sort of approach to do that. If you want batching, if you discover you've got two requests which are fine independently, but then for latency reasons you want to combine them together, well, now you have to add another endpoint to your web server and roll it out and update your client to use it, whereas with these protocols, you just run them both in a transaction and the JDBC driver will batch them for you. You don't even have to change your backend at all. And finally, you've got things like client-side load balancing, which is another often quite expensive thing that you pay for in the cloud that you can just get rid of, because unlike web browsers, client-side database drivers understand failover and load balancing. So you can just give them a list of IP addresses, and if one is unreachable or goes away, they'll fail over to another, if you have a good database, of course, or good database driver. So what are we going to make this solution out of? Again, I made this up for this slide. It's not a real thing. I'm calling it the POC stack. This is Postgres, Conveyor, which we'll get to in the next slide, and Kotlin. And this demo uses Compose Multiplatform, which of course you've heard a lot about, but you don't have to do that. JavaFX is also a very mature UI toolkit, which is good for business. It's got like very good table view controls and things, and you could use that too. And then I've also chosen to use Duke, which is a sort of DSL on top of, it's actually originally a Java library, but it has good support for Kotlin too, and it generates database access code, so you've got type-safe access. You don't have to write SQL. And then Flyway, which is a way of versioning your database schemas. So Flyway will work out what version of the database schema your database is on and then apply changes to get up to that. And then finally PL Java, which is a way to write server extensions for Postgres with Kotlin or Java. So by combining these things together, you can actually write everything in Kotlin as SQL from end to end, and you don't need anything else. Now, one of the reasons that people moved away from this design in the 90s and towards web apps was because the operating system vendors, primarily Microsoft, completely dropped the ball on distribution. And the tools available in that era basically left you on your own. They said, here's an exe file, put it on a Windows shared file folder, and then you're done. And that just wasn't good enough. And so people moved to the web, where you could very easily push new changes and iterate 10 times a day and so on. And that's, to some extent, still been the case up until recently. And so what I decided to do was solve that problem. And that's what my company does with this product called Conveyor. And the goal of Conveyor is to make deploying desktop apps as easy as the web. That's the bar we set for ourselves, because traditionally it's not been as easy, and that's one of the reasons people put up with all of this make work needed to make a web app. So what does it do? Well, it takes the output of your build system. You plug it into Gradle or Maven, or it also does non-Java apps as well, non-JVM apps, and it gives you integrated online updates without any code changes. It cross-builds all of your packages. It bundles JVMs for each target OS and CPU operating system. It optimizes them to shrink the JVMs. It handles native code for you, and it even generates a little download page with a big green button for you. And it does icons and sets of URL and blah, 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 all the things you would expect. And it's got some other features that you might not expect, too. For example, it will give you web-style update on start if you want it. So you can either have a mobile or Chrome-type update where it's transparent and in the background, but you wait a little bit when you push out a new version before your users get it. Or you can have it such that whenever the user starts the app, it does an update check and applies any updates in that moment. So you can force an update at any point, and that gives you a kind of web style. Okay, it's a bit slower to start, but you can push out updates many times a day if you want. It's a product, but it is free for open source projects, and in fact, it can integrate with the GitHub suite of products, so it will happily upload and create GitHub releases of your application, and that's where your users update from, so Microsoft pay your bandwidth bills in that case. It'll dump your download page onto GitHub Pages, and you can continuously deploy from actions, and it's a build system, it's not a SaaS or anything. You download it and you run it locally. Oh yes, and it makes it easy for Windows network admins to roll out your software as well in managed networks. So it solves a lot of these problems. And what I'm going to show you now is a demo of what that workflow looks like in practice. So this is Bugzino. It's not going to win any design awards. It's actually quite ugly because I'm not a UI designer. But it shows you what it's like to sign up for an account with this kind of fake little bug tracking application. And we're going to look at the code to see how it's done. So you can see here that this logs into the database as a guest, creates an account, and then a stored procedure. This is the download page, by the way, that Conveyor generates, but in this case, the app is already installed. It will send you an email with your registration code. This could also be a clickable link, but for this demo, it was easier to do a registration code. And as you can see, this email came from Postgres. Obviously, in a real app, you would change that. So you log in, and here is an app, and it's got search, and you can edit the records, and it's got loading flashes and all things that like Compose gives you. In fact, it's fast enough that the gray loading flashes are a bit annoying. Even though this is actually really running over the internet, this is going from, the hotel here in Amsterdam to Finland is where the server is there. Now in the code, this is what it's like to change it. This is the workflow. So we're going to add the logo to the sign-in screen. So that's a couple of lines of Jetpack Compose. We're going to bump the version number. And then we're going to switch to the console and just recompile the app. And then we're going to run Conveyor and say, rebuild and republish the app. We want to update it. So everything is rooted with code signing. That's one of the reasons you don't have to worry about certificate expiry in this, because code certificates expire, but when they do, it doesn't cause an outage. It just means you can't you have to renew to publish new versions of your software. And off it goes, and you can see it's a parallel incremental caching build system, which is why the building progress bar went to 50% so fast, and then it will sign your packages, and it even, Apple has a form of ahead-of-time virus scanning called notarization, which you have to go through, but the advantage is it doesn't run any virus scanners on your laptop. So while it's off doing that and dealing with all the things you have to do to release the desktop app, this is what the config file looks like. At the top line, there's a Conveyor Gradle plugin, and it doesn't add any tasks or anything. It just extracts config from your build. And then there's a bit more config here, so we restrict for this demo which machines we target just for speed. We say we want to have better startup time by extracting native libraries, and we want this updates equals aggressive, which we'll see in a moment. There's also a bit more config here, which is pointing the app to my server specifically, and this is also where is the download and update site, but also how do you put files there via SFTP. We've got the database connection URL, and then finally here we have this certificate, which is the SSL certificate of the server. It's hard-coded into the app, it's bundled, which means it can never expire, which means you've got no certificate expiry outages to worry about, and you don't need to go to certificate authorities either. This is just self-signed certificate. So it's very, very simple. Now, this is what it looks like when we run the app again. There's a brief pause, and now it knows there's an update, so it's about to do this. And you'll notice this is extremely fast, even though it's hotel Wi-Fi, actually. That's because it's only downloaded the blocks of the files that change. It's a Delta update, in effect. And as you can see, that was basically as fast as updating a web app. I don't think Gmail loads that fast for me, although I have an old account. So the user experience here is competitive with what you can get from a web app in terms of latency. Now, this is a Windows. What you're seeing here is Windows itself is actually downloading and applying these Delta updates. And there's a neat trick, which is that Windows will actually Windows is hashing the blocks of the application, of every file in the application, and it knows if you already have that data on disk, even if it comes from a different app done by a different vendor using different versions of the files. So if you've already got a Jetpack Compose app on your machine, either published through the store or through Conveyor, then Windows won't even download all of the other files. It'll hard link them, or if the files differ a little bit, so a hard link wouldn't work, it'll copy the blocks that are correct and only download the blocks that are different. And so in this way, you're amortizing the cost of actually getting that runtime onto the user's machine, and the first time it's done, the user has to download it. The second time, it's just straight through, and you're only downloading your app-specific code. So let's do a quick tour of the code to see what this looks like. On the left-hand side, we have the 3 modules. The common module, actually, it's only got about 5 lines of code in it, so we won't look at that. Just literally a constant and a function. The back-end module consists pretty much exclusively of SQL, and you can see here we've got V1, V2, V3. This is flyway. This is how you version your database schemas. It's got some SQL setup scripts where, as you can see, we're creating some roles and setting some permissions, but that's it. There's not a whole lot here. This code here sets up the database to load stored procedures written in Kotlin. And then on the back end, and then what we'll do here is quickly look at the front end before skipping to the back end. Let's go have a look at the sign-up screen. So here, as you can see, this code here is basically all UI code. It's text fields, it's spaces, it's modifiers, and then to actually interact with the database down here, we have an I/O button, which is just something defined locally. It just runs the action lambda in a background thread, and then on success or failure, it runs this on the UI thread. So you can do blocking calls here, and it's fine. So we log into the database as guest, which is a well-known username. It's very, very, very locked down. The only thing the guest account can do, really, is invoke a couple of stored procedures, which is what we're going to do here. And start user registration. This is actually generated code. It's generated by Duke. And what happens is there's a Gradle task that connects to your local database, reflects it, and then generates Java code to access it, or actually Kotlin code to access it. So we didn't implement anything here. Where that pops out is on the back end here, start user registration. It's the same function. All the RPC is vanished. It just is generated for us by the database infrastructure. And so here we generate the sign-up code and insert it into the table. And here on the server side, I'm not using any frameworks. It's not really, I just didn't bother, and sending the email. So all this is effectively using Postgres as an app server. You deploy to Postgres using a little script, and then it provides authentication and RPC and connections and batching and security and access control and all that stuff on top. So, and that's it. That's all it looks like. There's no other code to show. It's SQL and Kotlin, and yeah, that's it. There isn't any other language. So why bring this up now? Why this year in 2023 and not some other time? Well, I would argue there's a confluence of different factors that mean that this is now more viable than in the past and more worth thinking about than in the past. So one is that free database engines got a lot better. It used to be, especially when people were first doing database-backed GUIs in the 90s, that you basically had to pay a lot of money for a commercial database. These days, the free databases like Postgres and MySQL have just got a lot better, and they've got, in particular, a lot of the security features now that you need to implement this, like security definer views and row-level security. And these features were added in the last handful of releases of Postgres. By handful of releases, I mean major versions, so some, a few years ago. A lot of work, in particular by cloud vendors, has been put into Postgres, in particular for connection scaling. And there's also now open-sourced things like distributed Postgres and so on. But also just hardware got a lot better. With this design, users are stateful. So they hold open a connection to the database, and that uses a bit of memory up until the database decides, I need that memory, and you've been idle too long, so I'll disconnect you. It's a bit different to a web server where the browser will very aggressively disconnect from the server. But although it may sound a bit too primitive, like surely we need lots of caches and things around the database to protect it, with modern hardware the answer is often no, because you've got an enormous amount of RAM, very cheap. Maybe not so much if you're renting like a VM in Amazon Web Services, but if you look at the actual cost of the hardware, you get it from a cheaper provider like something like Hetzner or whatever. You can get a lot of RAM for very little money, and then you've got incredibly fast flash disks as well. So actually, in many cases, you can just allow the database to absorb the query traffic, and you don't need additional layers. It works fine, even to quite high levels of traffic, and there are load test results online that you can see. And then finally, deployment got better. Windows finally now actually has a built-in package manager, and it's actually fairly decent in terms of its feature set, at least. As you saw, the actual act of installing or even delta patching was extremely fast, even on very, very poor Wi-Fi. and then a lot of the remaining work was like, well, it's just lots of weird new tooling to learn, and it's kind of not very good developer experience and so on, which is why we built Conveyor to make it easy. And it does now make deployment simple. As you saw, it was literally you just press enter and it releases, and the actual config fit on one screen with big fonts for a presentation, right? It wasn't a very complicated config file. And yeah, like apps are kind of big and bloaty, like Jetpack Compose. Well, actually, like the Skiko rendering library that Compose uses is the same size as the entire JVM for some reason. Who knew vector graphics is so complex, but it is apparently. But that's okay, because actually network bandwidth has also drastically increased from the time when people first started moving to web apps. Yeah, well, not in the hotel here, but at home, I have a completely bog standard internet connection for Switzerland. It's literally the default option sold by the biggest ISP in the country. I don't pay for a special connection. And this entire app can download and install in about 6 or 7 seconds, because that's just like how fast the servers and connections now are. And then finally, desktop UI got better as well. We've got nice modern toolkits like Compose with modern languages like Kotlin, and you can share the code with mobile now. And the JVM has also become much better optimized for the desktop. In particular, you know, it used to be that, oh, you target the JVM, your app uses a lot of RAM, and users don't like it, and et cetera, et cetera. Well, the web got bigger, and the JVM got smaller, and it's got a lot better than it once was. And in particular, especially now with GraalVM native image, which is just on the verge of getting support cleanly out of the box for all this stuff, it makes a massive difference. Just a few days ago, someone who's been working with us, actually, there's some guy in the open source community who's using Conveyor to ship this app, and he's been experimenting with using GraalVM to compile a Compose app to native code. So there's no JVM anymore. It compiles down to a single executable, and it eliminated 100 megabytes of memory overhead. So this app went from 35% CPU to do an animation and 160 megs of RAM to 62 megs of RAM, right? And 25% CPU and much faster startup time too. So that is a massive difference. That is a more than 50% reduction in memory usage. So at this point, you're getting competitive with native apps. And it's not that hard to do. I think he's using like some beta release of GraalVM, because, you know, adding support for Aut and GUI libraries is something they've just been doing. But as you can see, this is actually getting very, very practical now, and all the pieces are falling into place. And then finally, you know, there's pressure from the other side. Not only has the whole desktop development experience improved significantly, and databases have improved, and this is now, you know, a lot more technically viable than it once was, but the web stack got more complicated at the same time. You know, we're now pretty regularly seeing people get upset and write ranty blog posts about how complex front-end development has become. You know, it used to be that you wrote some PHP or Perl and you copied it to the server, and that was it. That was the deployment experience. So much, much easier than it is today. But the problem is that to keep up with the UX expectations set by mobile platforms has required, you know, this ever-increasing set of libraries and frameworks and compilers and other things that have been layered on top. And so as a consequence, you know, a lot of this stuff has now become quite hard. This has been combined with exploding cloud costs. So if you can optimize your hosting costs, it's actually worth doing. And then finally, you know, a lot of services today, they actually start with a mobile app, and then the web version is basically the desktop app, and you're not really meant to use the web version on mobile. But it ends up being highly duplicative, especially because some people will say, well, actually, I would like to use the web version on mobile, so you end up maintaining like 4 front ends. You've got like iOS, Android, web desktop, web mobile. And it's very, very expensive, hence efforts like Treehouse and Redwood and so on that was taught in Jake's talk to try and reduce that cost. And so, but if you can just go straight from your Android app to the desktop with nothing in between, you don't have to, and you know, you just change a few layouts, you don't need anything in between, then this is drastically cheaper than re-implementing everything on top of a web app. And all you would be doing by re-implementing everything on the web is basically optimizing out like a few seconds of download time if people are on, you know, good connections. Now, if you are trying to go viral and build the next social network, you know, and you've got a lot of very non-committed users, then maybe that initial download time still matters a bit. It doesn't seem to matter much on mobile, but maybe on desktop it does. Which is why I say you would use this for like internal apps, business-to-business apps, dashboards, this sort of thing where development time matters more than like, you know, initial first run time. So having, you know, experimented with this and done some done some prototyping and you've seen a demo of what the workflow is like, what are the next steps to explore this stuff? Well, there's a whole lot of things that I really need or want. So one is that this demo it's not a template you could copy paste it and just start replacing code, but it would be nice if it was a proper pre-canned template so people can get started really easily. Especially it'd be nice to have a pre-canned Docker image of Postgres already set up with the stuff you need to run Kotlin in it. It's not that hard to set up, but it's still like a checklist of things you have to follow. So it'd be nice to have that be pre-packaged and pre-canned. Tutorials, all the usual stuff, right? Like how do you really make this work in practice, and what are some of the best practices? Finally, obviously a more complete sample app that's better looking would be nice as well. And then there's features. So one of the things that, I don't know, we might add it to Conveyor, or we might do it something a different way, would be how do you have users log in not with a username and password, but with something like OAuth and something like SSO? And can you do it once so that it can be well audited and people can't accidentally screw this up, which is a very common, as I mentioned, very common source of web app exploits. And then you saw the and the final thing is you saw the aggressive updates mode where you literally start the app and it just updates to the latest version. But what happens if you want to update the app whilst the users are running it, right? What if you don't want to wait for them to actually restart the app? Can you update it on the fly whilst it's running? Yes. That's not hard to do. JVMs are very good at this sort of thing. And it doesn't require the sort of hoop jumping that people do on mobile where they have to use JavaScript engines and things. But it's not built into the sample and it's not yet built into Conveyor. So it would be nice to have that so you could iterate many times a day, because especially in the early days of a project, that kind of iteration speed can be really useful. So here are some objections that often come up when I suggest this to people. And like I said, it's a bit out of the box thinking at the moment. This takes people by surprise when I say, why don't you just do this? And people say, well, I can't do that. This is clearly, you can't, everyone knows that you can't do that. So we work through the challenges one by one. And one of them is scaling. So, people say, can it scale? And the primary scaling bottleneck in this design is, well, firstly, your database has to be able to absorb the query traffic. But like I said, these days, especially if you scale out read-only replicas, that's usually okay. And if it's not, well, scaling write throughput and transactions is really hard anyway. Using the web stack doesn't make that go away. So the primary scaling bottleneck is really the memory cost of idling connections, because a connection is more expensive, and Postgres in particular is not really optimized for huge numbers of simultaneous connections. But most databases, and Postgres is no exception, do have proxies and bouncers you can put in front of these things, which scale the connection pool a lot better. You could argue at this point it's no longer 2-tier, but this 2.5 tier is generic, right? It's not specific to your app, so it can be bundled into the deployment procedure, and this allows you to scale up the number of connections much, much higher. And also, you have to consider that this is basically a replacement for load balancing, because if you don't need these bouncers, or if you integrate them with a database deployment, you don't need any sort of CDNs or load balancers, because the app itself can do that, right? The app can do something like just select the database replica that's closest or has the lowest ping time, and you can get rid of all of the DNS load balancing and all the stuff that has to be layered on top of web apps. All of which, if you think about why you need it, is fundamentally a workaround for the fact that browser networking stacks will just give you an error page if you can't connect to the IP address you get from DNS. Browsers don't have any concept of well, I've got 5 IPs here, and I'm going to try each one in turn, or I'm going to locate the nearest, and they will just give up rather than fail over or try to reconnect transparently. But when you're outside the browser, you can get rid of all of that, which means you can simplify your whole hosting setup. And then finally, because drivers can be configured to reconnect, or you can use client-side connection pools and things, you have a trade-off where you can say, well, here is the amount of RAM I have, and at times of the day when I have fewer users, I'll just allow them to idle longer. And then at times of the day when I have more users, I'll like more aggressively disconnect idle connections. So you're trading off RAM on the server versus like latency on the client. And if you can get it to the point where all of your users are able to hold a connection open the whole time, then of course your latency is very low. And if you need to, allow those to churn a bit, then button clicks will take a bit longer because they have to like set up a connection. It's not much different to the web in many ways. What about security? Well, the whole thing is oriented around database role-based access control. So you do have to lock down your database. And you saw a few lines of SQL in the setup scripts that are doing that here. There are some limits to this. Locking down access to data is straightforward and very well supported. Locking down access to your database schemas, on the other hand, is less well supported, at least in Postgres. So if you are worried about like leaking the fact that a feature is about to launch by the fact that new database tables appeared, if that's the kind of problem you might face today, then indeed you're going to have a hard time with this because users can just log in and say what tables are there, or even if they can't query them, they can at least see they exist. So that's something that would need a bit of work. If you're very high profile and you would want to put your website behind like a DDoS defense, that you can do that with databases because the DDoS like Cloudflare and Akamai and Encapsula and these companies can protect raw TCP connections, but they don't have as many options to filter out bad traffic and bots and things. So that's one thing. And then finally, these things are usually written in C, so they are pretty secure, they're pretty clean code and well written and so on, but they are, internet-facing programs written in C. So that you do have to think about that a bit. And there are a bunch of possible solutions for all of this. For example, I already mentioned there are already multiplexing proxies that just reduce the load on the database, but you can imagine having a slightly smarter one that's written in something like Kotlin, for example, with Loom, so it's memory safe and which is applying, white lists of queries or is preventing clients from querying the schema reflection tables and applying a bit more security on top, right? Like verifying queries passed before passing them through, that sort of thing. Other challenges, DB as a service is often a popular thing. I mean, it's expensive, but people often like to outsource the running of their database to cloud providers, but most database as a service providers don't allow arbitrary server extensions, like PL Java, which is what I'm using here. Sometimes this is about sandboxing, sometimes it's not, sometimes it's just, they start with like, for example, I think Amazon offer V8 and JavaScript as a way to extend Postgres, but not Java or Kotlin. So you could try and do it with JavaScript and Kotlin.js, but I prefer to just install Postgres in Ubuntu and manage it myself. A lot of Linux distributions have been making this as easy as possible for quite a long time, so database administration is not that hard to learn. But it's not a cloud service. Maybe some people will start offering this for Kotlin and JVM users in future. And what about debugging and testing? Well, actually, it's not that bad. You might think that it sounds like it would be painful, but you can attach IntelliJ to a Postgres session and debug a stored procedure just fine. The Java debug wire protocol is a protocol and was designed to allow that for a long time. So just the same way you can debug a remote Java server, so too can you debug a stored procedure running in Postgres. And then there are libraries that allow you to spin up embedded databases for integration tests. And of course, you can also run your server extension logic against an in-memory DB because it's just Kotlin functions and a simple JDBC connection. So that's also pretty easy to test. So this is not quite as bad as you would think, right? It's like debugging anything in an app server, basically. And so that's the contents of my talk. Now, like I said, I suspect your reaction to be a mix of horror and wonderment that someone may actually propose this, but I'm hoping that you'll go away and start thinking through the objections and saying, well, are these solvable? Or, can this be done? Because the benefits in terms of code size and simplicity and productivity are there, and you can go look at that repository and see that for yourself, just how simple it really is. So thank you for listening. That's the talk, and does anyone have any questions? Thank you. Yes?
Thanks for the talk. I definitely see a niche for this, but I think it's still a niche. I think the main reason why I would really hardly consider going that direction would be security, meaning It's easy to do if you share everything or share nothing between users. But if you have more complex cases when the decision if something should be visible to other user or editable to other user, then that making that security policies on database side would be really, really hard. And it might turn out that in version 1, your application would be super fine, but then there will be version 2 with more complex requirements on that security side, and you would need to do something about that. And there is no easy exit from this architecture.
Well, so I actually didn't show this in the code tour, and probably I should have done. The way the demo is set up is that users have no access to the tables at all. All access, read access is through views, which, obviously there are arbitrary queries, so you can impose whatever access control logic you want at the view level. And all writes go through stored procedures, even simple writes. So if you want to impose a policy like you can edit this bug, but the timestamp, the last edit timestamp must always be accurate, then you just implement that as a stored procedure, either in SQL if it's simple, like updating a timestamp would be, or if it's much more complex kind of logic, business logic that you have to enforce, then you can just replace that stored procedure with one written in Kotlin, and at that point it's like implementing something in a web server. You can do whatever logic you want. So I believe, and I mean I haven't thought about this incredibly deeply, but I do not know of any access control or security policy that cannot be implemented in this way. And the example of like how do you implement open signup was a bit of a test case. What does it look like to do something you wouldn't normally be able to do? You certainly couldn't do that with SQL, right? Unless you were, I don't know, probably Oracle can do it, but not on Postgres. And so that was a test of like, well, can we make a guest user with no access to any data at all, but which can nonetheless invoke some logic that updates tables and so on. And you can do it. It's not that hard. So I think you will always be able to implement what you need. In terms of exit from this architecture, the exit is, if you need to, you either start implementing more and more logic using stored procedures and in Kotlin, or you add a web server on top and you go back to using HTTP and REST, which is basically the same conceptual design but with different protocols. And then you start moving more and more stuff behind this custom protocol until eventually you cut off access to the underlying web server. So that's the exit. Any other questions? Yeah. Oh, so I guess this gentleman is a bit closer. We'll get to you next.
Thank you. In terms of what you can do on the with PL Java or stored procedures, is there some limitations? Like, for instance, accessing other servers or doing network calls and all that?
Right. So it embeds a full JVM. So on one level, no, there isn't. What you have to watch out for if you experiment with this is a PL Java uses the Java sandbox and will sandbox your stored procedures by default. And it does this even if you label your function as unsandboxed, because the author's idea of unsandboxed is you can access the file system. And then it's like the default set of applet permissions, which they're actually using the security manager, which is there, and it still works. So if you want to enable your stored procedure to do network calls or do other stuff, you need to, and the demo repository shows how to do this, you need to add that to the policy or disable sandboxing completely. So you can do anything, you just have to be aware of that. I guess eventually with newer Javas that will go away because they're getting rid of the sandbox. But for now at least, the server-side code is actually sandboxed, which is more than you would get on a web server, right? Normally you would have to set that up explicitly, and it's not done there.
Thank you.
And I should say that you saw it send an email, right? That's like a network call, so yeah.
Hi, thank you for the talk. My question goes in with the flyway and the database connections. Is it correct, did I understand it correct, that every desktop app has its own database? Is this correct? Or is it shared by different desktop apps?
Well, if you have like 5 users and each one has installed it, they're all connecting to the same database.
So how do you manage these flyway updates if the schema changes for this app? What is done there?
Yeah, well, it's the same as if you have multiple web servers and you want to do you want to do an update without an outage, right? You have to evolve your schemas in a backwards compatible way, and then make sure that your clients are updated. So if you want to change the format of a column, for example, you would add a new column. run a script to translate that and then update your stored procedures that are doing writes to update both columns. So now you've got your database synchronized, and the old data and new data is being read by old and new versions of your client. And then, after users have restarted and they're up to date and no one's reading the old column anymore, you can drop it. But you have to do that backwards compatible evolution of the schemas.
Goes more complexity in this creation of these update scripts.
Well, it's no different to if you run, a web app without outages, right? You would have to do the same. In the moment you have two web servers connecting to one database, you can't update all the servers atomically. Well, I mean, you could try, you can schedule maintenance hours and stuff, right? But you would still have that problem of needing to do a backwards compatible schema updates. Now, one of the things that I would like to add to the demo is automatically querying what the current schema version is. And in fact, Flyway stores it in a table, so you can automatically query the Flyway table to say, am I out of date? And if you change the database schemas at that point, then the next time the user clicks a button or navigates to a screen, the client will say, am I out of date? And if the answer is yes, then at that point it says, sorry, I've got to restart, right? And then it will restart, and that triggers the update procedure, and then you're advancing everyone in an atomic fashion, right? But for some users, they do ask for that. We have customers who they're not doing direct to the database, but they don't want to preserve backwards compatibility in their protocols, and they ask for that, but we haven't implemented that yet.
And one further question to that is, with what permissions is this running these Flyway update scripts? Because if I understand correct, the user, your app is connecting with the user, with the new created user to the database. So this user permission, or with this user, this update scripts is running. Is this correct?
Well, so Flyway will run as a database super user, and normal users log in as, actually the role is called normal user.
Is it triggered from the client then?
No, if you want to update the database schema, you trigger that from a developer or ops workstation. So you have one guy, whoever is the database admin would run, it's actually a Gradle task, you run Flyway migrate, and then it figures out which version you're on, and then it runs the script for the next versions to migrate your schema to the new version.
So outside of the app, the update of the schema.
Yeah, so the end users are not triggering schema updates or anything. That's done in the conventional way, just in the same way you would for any web app that uses a desktop. A database. That's not any different.
Okay, I see. Thanks.
Okay. All right. Oh yeah, sure.
I'm not sure if it's a very smart question or not, but okay, so maybe you can drive me through it, because I don't understand this point. So let's imagine that I have a mobile application or even a web application, and then I want to use your product as well. So basically in the mobile application, I also need an API, right? I also need to write an API, and in your application, basically, there's this layer, or basically this layer of API. It's not there at the first place. So I have to speak from basically the front end to the database directly. So my question is, if I will write an API on the mobile application at the both cases, then basically there's going to be redundancy in terms of the procedures that I'm going to have on the DB level, right?
Right. So there's two answers to that. One is actually you can also connect. Android has a full Java.SQL implementation, so you can do the same thing on Android. So that leaves iOS. And there certainly are database drivers. iOS runs C++, right? So you could actually do the same thing there too. Now, I have not written a demo of how to do that. That would be something that we would want to add to the repository, so we have a completely full stack solution there. Or you say, and you can say, well, let's just do it conventional way with mobile and do an API. And for example, a midpoint here is to use something like Supabase. And what they do is they run Postgres for you along with an extension called PostgREST, which basically auto-generates a REST API on top of your schemas. So, and then they provide a custom library that you can invoke from Java and Swift. So that's you're not getting all the benefits of the database protocols there with batching and RPC and stuff, but it's sort of halfway there, right? It's not one you have to design yourself.
There's one additional point, which is that because you're writing it in Kotlin, right? You can have this common module that you basically had. You can have all the code that is common basically in this common module, and then you just have to have a small API module or a small API project that actually uses also this common module, correct? or that won't work?
Yeah, and well, the common module, as you saw, has almost nothing in it here. It like literally, like, it's just a bit of sharing a bit of logic for like email validation and stuff. But yes, you could use Kotlin multi-platform and then put like shared UI in your common module and things. Yeah, I think we're out of time. Sorry, I should let you guys go, and it's the end of the day. So thank you very much for listening, and I hope that was thought-provoking. And thank you very much.